in the past we had to look, and there were trade-offs. We could give you all of this, but not all of these people. We couldn't give you all these users, but we can give you all this data, or vice versa. We can get all of your users in there, but it's going to be a limited set. We don't have the horsepower, we don't have the money to build that infrastructure, whatever that might be. Well, here's a look at traditional data architecture, and I chuckle a little bit because this is kind of maybe overdoing it a little bit as far as the connections and things go. But if you think about it, we've had all these data sources off here on the left hand side. You've got your OLTP and your enterprise apps, your third party stuff, your web stuff, all that IoT pieces there, and we have to work with all of that on the consumer side. Over on the right hand side, we have to go through all of this stuff. First, we have this integration process, and then we've got to transform the data using ETL or ELT, different things like Spark, or maybe it all goes into the data lake, stuff like that. And then after that, we still have to normalize it and take care of all the aggregation before we can send it off to the analytics side. And that's just, there's so many steps there. It takes a lot of time, a lot of effort. And by the time we're analyzing, honestly, the data is old. I mean, old in our world now is I have people complaining when they find out they're going to be getting yesterday's data in their reports today. So old may be 2 hours from now, depending on who you are. So Snowflake is a totally different architecture. Okay, and it doesn't matter whether you're using the Google Cloud or AWS or Azure. It's the same architecture on top of the whole thing. So all of my data sources are into Snowflake. I can do all of this stuff and out to my consumers like right away. I can do real-time or near real-time analytics on my work, depending on how I have things configured. So say you have an environment that's not highly transactional. The data is coming in as the data comes in, and people are, say I'm a Tableau guy, so maybe my data is in extracts, and I set those extracts to update, every half a day. So I update at noon and I update it at midnight. So my data is a half a day old, but maybe I'm working in a world that's more transactional, and I'm going to go to live. And so the moment that I get a transaction in there, my Tableau that's working on live data is actually querying or bringing in that very same data that just took place, seconds ago. So this new architecture is incredible and absolutely the thing. So what's under the covers? How does it really look? So built on top of any of those platforms, we have our centralized data storage. And I mean, this used to be the big dealie of Snowflake, and I think it's still a big deal, but there are some other things in Snowflake we're going to talk about soon that really are they add to this like icing on the cake. But Snowflake has the centralized data storage, and then they've taken and removed the computing component from it. So the part that we would call the data warehouse, or the part that does all the work, is separated into a separate compute layer where we have the ability to create clusters of different sizes and of multiple nodes to do the work either faster or do the work by more people. That concurrency, so we don't have a concurrency limit anywhere. And then on top of that, we add the cloud services, so the security, the governance, that ability to manage things, or the ability to go backwards, sharing and collaboration, all those things that really, when you start putting those in, they truly differentiate Snowflake from everybody else.
Yeah, Tim, if we can go back one slide just for a second.
Sure.
So I think this is a really good takeaway slide as well. If you get a nice, good mental picture of this in your head, this 3-tier piece of the architecture. This is really critical to understand the fact that storage and compute are separate. That's a big deal. But the special sauce is in the services and the engineering behind that to allow folks to work on multiple compute clusters to be working on the same, what appears to be the same data set, or it is the same data set, and manage all of those transactions and ensure that that's done in the right way. So, Jordan, I don't know if there's additional points you would make here, but maybe just the sizing of compute clusters might be interesting on the t-shirt sizing, but if any other comments on this slide?
That's actually too.
Yeah, this will start to make a lot more sense as we get into the hands-on portion, and you can see how the compute clusters manifest themselves versus storage. I think the other thing to note here is this is where the new unlimited scale and elasticity comes into play. The storage in Snowflake is based on object storage in whatever cloud you're running in, right, across the 3 clouds. So Azure Blob Storage in Azure, S3 and AWS. You will never run out of storage in Snowflake until the cloud region you're running in runs out of object storage, which is practically unlimited.
Impossible.
Yeah, it's impossible. Nobody's ever been able to do it. Additionally, you have no limits on the number of compute clusters that you can create within a single account. So if you wanted to create 30 64 node clusters to operate on your shared data, you can do that. If you want to go up to 100 64 node clusters, you can do that. There is no upper limit. You simply pay for the compute seconds that you're using. So where in a traditional on-prem or even first gen cloud data warehousing world, there is a limit of compute and storage. There is a 100% level. You only have so much disk, you only have so many CPUs. One Snowflake account truly is nearly unlimited. There is no 100%. You can always go provision more. That's the big mind shift in Snowflake versus other data warehouses that are out there in the market.
Hey, Jordan, this is Ravi. On the point of differentiation, right? I know Amazon came out with RA3 now, and you know they also have storage and compute completely segregated. So is there any comment or data point we can have just to be proactive and we'll have the objection?
Yeah, so RA3 in Amazon, for those of you that have an AWS leaning, the RA3 node type can be used to build a Redshift cluster. The reality is Amazon decided to make the separation of storage and compute an infrastructure thing versus a true separation thing. So all RA3 means is within each node, within your Redshift cluster, you can add more storage to one of those nodes. So if you had 4 CPUs and 2 terabytes of storage, you can have 4 CPUs and 4 terabytes of storage.
Right.
But that is fundamentally different than what Snowflake is doing. Snowflake allows you to stand up as many clusters as you want, not change the specs on one node, but entirely new clusters. So it's a different way of implementing what sounds on paper like the same idea. In actuality, it is very, very different.
So what are our requirements here? One is a platform. We have one platform, one copy of the data, and many workloads. So whereas in more traditional worlds, I may clone something and have the two different data sets, literally same amounts of storage, have to be doubled, all this kind of stuff. In this case, in Snowflake, we keep that one set of data, that one stored data set, and then we can have many workloads against it, which is really what Jordan was saying before, is that we can put as many clusters at it as we want to against that same data that's being stored. So we're not making multiple copies and doubling the size of our storage. The data is secure. governed access to all data. So we decide, the user or owner of the data decides who can see what and when, and then also when they can no longer see the data as well. And all of those things are very easy to take care of in the Snowflake environment, which we'll see some more of that in the hands-on as well. And then the near zero maintenance and being as a service, literally, as was mentioned earlier, Thursday there's going to be a new upgrade or a new version of Snowflake, and everybody's going to have it. It's not like I have to get on there and click on a button and go, oh yeah, upgrade my stuff to this week's release. When I log in, it's going to be there. It's already taken care of. So I'm not the person that has to maintain that. The only thing I'm really maintaining are who my users are, what they can get to. Do I want to change settings for size or number of clusters, things of that nature? Do I want to add another database? Just things of that nature. I have no hardware to maintain whatsoever, so I never worry about any of that. Am I running out of memory or am I running out of storage? It's not possible. So, and then of course that unlimited performance and scale, and that circles back to what I already said, is that you can, and what Jordan said, throw as much at it as you want. If you want 164 node, dang, that's huge. 164 node clusters. I mean, that's just wow. That's big, and we're going to hit that again actually in a little while. So the Snowflake world is growing like crazy all the time, and I should have put us in there, but look at all these people in here, all these companies that are creating data, sharing data, working with Snowflake or allowing Snowflake usage, integration with Snowflake, that sort of thing. It's growing all the time. How fast is this growing, Jordan?
I mean, it's hard to quantify, right? Most tools out there in the data world we're already partners with. We're rolling out native connectors all the time, and very honestly, just about every services firm on the planet wants to be in the Snowflake Partner Program now. So I mean, it's any tool that you can connect via ODBC, JDBC, we can work with. Any services partner that works with any of those tools obviously wants to be our friend. So it's expanding very rapidly.
Great. I mean, all of our partners are listed on here.
Yeah, I was going to say, we've got some of our partners in here. So we're also partners with Sigma, which is a spreadsheet / almost Excel type of tool that sits on top of a cloud data warehouse. So it connects very nicely with Snowflake. We're obviously Power BI. We're soon to be Google Cloud, and I think everyone knows that we're Tableau partners as well. So and Alteryx too. Yeah.
So the customer journey with Snowflake, and I'm actually going to ask Andrew to weigh in on this one more so than me, because he's a salesy guy.
I can talk through it. In fact, I'm going to talk about this on Friday as well, but Snowflake starts out, you can get a free 30-day trial during which you can burn through a number of credits, which basically map to cycles of compute. And so typically you really just need a credit card to get signed up and start going. But typically the journey really starts more at hey, are we ready to move to the cloud? Yes or no? What are my options? Once folks are committed to move to the cloud, then it becomes a simpler conversation, right? Because Snowflake is clearly differentiated in the sense that, one, it's present in all three clouds. You can switch between clouds if you want. You can back up between them. You can query between them. And you can kind of manage your overall account across all three if you want it. So that really differentiates Snowflake from any of the others where you'd have to kind of commit to one major cloud provider. Typically, once folks do that, they want to understand and experiment. So there is some sample data that's already out in Snowflake that you'll see. that folks can use to kind of play around. But typically, folks are going to want to bring in their own data. And so in this journey, the next real step for them is what's the best way to get data into Snowflake? So there are many, many different technology partners at Snowflake that will do this. We have taken the stance as a company that we're going to move forward with the Alteryx plan because we feel like Alteryx is kind of a Swiss Army knife when it comes to overall data and analytics, as opposed to kind of a one-trick pony that just gets data in. So we're really trying to look at what we call our modern analytics platform, which is meant to be end-to-end solution. So Snowflake is the warehouse and Alteryx is the way we get data in. But we do have accelerators where we're trying to help customers get that done faster or give them kind of standard ways to do that. Then usually once they get data in, it's understanding security and roles and comfort and all those things with knowing that your data is secure, understanding how the roles work, understanding what your consumption is going to look like. If you're going to get a bill at the end of the month, you want to hope that you understand what goes into that and what to anticipate. So understanding how do we monitor usage. So one thing that we've developed as a partner is a dashboard in both Tableau and Power BI that hooks into the schema behind the scenes in Snowflake and allows our customers to see how much they've consumed and kind of predicting how much they may consume by the end of the month based on that trend. It also allows them to do, or us to work with them to do some optimization around the size of the cluster. How big do some of these workloads need to be? Loading data might be different than just doing queries versus doing something to support Tableau, hitting it with its query language. So anyhow, so once you get data in, it's getting data out, understanding the value, but then it's really coming up with what's my roadmap look like? How do I rationalize this? How do I create, if I'm not the buyer myself, how do I let my executive team understand the value that we're getting from this platform? When do I bring on different data sources? It becomes very much a roadmap for like any other data warehouse. It's just you happen to be your target is Snowflake. But then once you go live, it is monitoring your usage and kind of just ongoing watching how things are being used, optimizing things, and tweaking. Jordan, anything you would add to that?
The only thing I'd point out in this journey is anywhere you see the little pink slices of pie, that is where services, either Snowflake's PS or our partners, have a chance to do quite a bit of billable work. And it starts early, right? It starts way at the beginning as soon as we identify a use case for Snowflake. So that's why we're here, is to enable everyone on the phone to be able to be a part of these projects, to help our customers get from, okay, yes, we like the technology, let's see it in action, to a production go live. Making that as seamless and as fast as possible is exactly what we're here to accomplish. So there's a lot of services that go with Snowflake because we're delivered as a service. There's not a lot of work on the Snowflake platform itself, other than integrations and writing queries. There's a lot of services around the ecosystem of Snowflake, rewriting your ETL routines, standing up your streaming data pipelines, transforming data in database. There is a lot of services that go into that transformation from a legacy data warehouse to something modern like a Snowflake.
The limited administration, or near zero, we talk about, you simply load, share, and query your data. And we're going to actually show that here in the hands-on portion coming up. But you'll see when we're in there, the administration is actually really, really very light, very easy. There's a very easy to use user interface, and the concepts are not difficult. So it's pretty easy. No more need for that. Those guys all in the basement with the racks and racks of stuff and pounding their head on the wall all day long. You'll love it. So our traditional ways of sharing data here, really, in the past, if we share data, we're copying files in FTP or SFTP maybe, or in buckets. We're building, we maintain, and calling APIs. There's a lot of programming involved in this stuff in the past. So even when I'm working in the Tableau world, I'm having to use APIs to get to some of this data because there are not necessarily drivers for everything. And then we've got to build these ETL pipelines. It's not super easy all the time. We're taking this data stuff, and for me, it's into a SAP Studios or a HANA Studio, so I can get my ETL stuff all written, and then testing and going back and changing it again and testing and going until I get it right. And we're creating data marts for people. And the gaps here is that we copy and we move data. It's costly. We're constantly doing these things that are slow. There's chances for error all over the place. Every time it's touched, there's a chance of an error. It costs a lot to maintain it. It's delayed. Like I said, even the better way is the Snowflake way. So in Snowflake, and we've said it a few times, but we got to drive it home. There's only one copy of the data, and we provide secure access for users and groups and people to the things that we want them to see, the things they need in order to get their job done, but not to everything. They're not going to walk away with the farm, so to speak. And because of the way Snowflake is designed, not only can we share between people in our own organization, but we can share our data outside as well in a secure way. And that is totally foreign in most worlds. So here the differentiators are that there's no moving, there's no copying. It's that one single set that's live. It's always the live data with no delay. And then we share personalized secure views. Like I said there, it's governed, it's revocable. And if tomorrow I decide that you shouldn't be in there, then you're gone. And it only takes a moment. And then it's globally available across clouds. So I'm sharing my data here in my AWS EC2 instance where it's been built, and I'm sharing it with my people over here, say at Ivy Tech, and they're in the Google world. No problem. It's not an issue at all. And then there's the data exchange. And really, I'm going to let Jordan talk to you about or the data exchange, because this has come a long way since the last time I looked at it.
Yeah, we're gonna use the data exchange in our last hands-on lab today, so you'll get a good chance to take a look at it. But the important thing to note here is that what Tim just talked about, the data sharing technology, is the underpinnings for all data movement between Snowflake customers. So data sharing is an A to B operation. If Ivy Tech wants to share data with the state of Indiana, they can do that across clouds via the Snowflake platform, but it's only A to B, right? State of Indiana and Ivy Tech had to get together, have a meeting, and decide that they were going to share data with each other. The data exchange is a pull versus a push model. The data exchange allows you to publish data sets into a UI within the Snowflake interface, where your data consumers can come request access to that data share. So it's simply a wrapper and a UI built on top of the data sharing mechanism that allows your data consumers that you invite to the exchange, right? It's governed, it's controlled, but you can share data sets with a potential, dozens of other entities. They go into the data exchange UI and say, ooh, that COVID-19 data set's pretty interesting. I would like access to that. You approve that access and the share automatically goes into place. It's just a different way to begin the data sharing relationship. Instead of A to B, it's one to many, right? It's one provider making that data set available to many consumers if they choose to opt in. We will absolutely take a look at this later in the meeting.
Yeah. And like with the A to B, it's still live without delay, no moving and copying. So it's all really cool.
And I'll hit this one too, Tim.
Okay.
So the Snowflake Data Marketplace is a step up from the data exchange. The Snowflake Data Marketplace is global and available to all Snowflake customers in all regions and clouds. These are public data sets or sample data sets that Snowflake customers have published so that all 3,500 Snowflake customers can see their data listed and request access to that data. Some of our customers use this as the data that they have in their Snowflake environment. They will publish a sample of very valuable data that potential customers can come play around with, see the value in the data, and then begin a business relationship to buy that data on a subscription basis and use Snowflake to use that, to share that data with the new data consumer. So the marketplace, again, from a UI perspective, looks and feels and acts just like a data exchange, except the number of potential consumers is every Snowflake customer in the world. We have a company in Indianapolis that's doing this. They're an HR tech company. They are sharing job postings and job fulfillment data for the entire country in a kind of a benchmarked, de-identified type of way. They're sharing that to all 3,500 Snowflake customers if they choose to use it to enrich their data sets and drive their own analytics. So it's a way to market yourself. It's a way for your customers to be known to every Snowflake customer in an ever-growing environment, and to potentially start new relationships where you're monetizing your data to other data consumers. We'll take a look at the marketplace as well.
Starting on the ingestion side here, maybe you're using one of these tools to get the data in, and we have this ability to create these warehouses as represented by the gear down there, and excess is this. Snowflake has this thing they call t-shirt sizing, so you can have an extra small warehouse or a small, medium, small, large. Is there a medium, large, extra large? We go up to 4XL. So we have all these different sizes in there. So imagine you've got this regular data load for ingesting the core data into your platform. And some of that data you load daily, monthly, quarterly, but since the data is set, rather predictable, it's manageable in size with a predictable load. So the extra small compute cluster for that workload is just fine. So at the very same time that we're ingesting data, we're also doing some data transformation work. And that data transformation work, if you look at the arrows, is moving in both directions. So out to our transformation software, and then back into the database. It's running at the same time that we're bringing in more data. Instead of extra small, we're using a small cluster. Runs a little bit faster, handle the increased load that we'd have to go in both directions there. So, and at the same time that we're doing that, we have all these apps running. In this case, this example, it's a finance app, and finance is crunching the numbers all the time. So they're using a cluster that's listed as large, and it's the same data. Everybody's going to the same place. Nobody's having any problems. Nothing's slowing down. Nobody's got some record lock that I can't do anything with because Joe Schmo's over there doing his thing. We're still moving just fine. So over here, the data science guys, they're working on new models and things like that. So they've got data going in both directions. And once again, they're hitting the same data. They're using a large cluster. And then marketing is on the same data. Again, still, nobody here is having a problem with speed or not being able to update something, not being able to grab data because of concurrency issues. None of that occurs. So the marketing
Tim,
guys are go ahead.
Sorry to interrupt. I wanted to throw something in here because I think it's inherent to the slide, but we should at least discuss it.
Sure.
So with each one of these compute clusters, these are physically separate computing entities.
Oh yeah.
So we talk a lot about the separation of storage and compute, but inherently to here, there's also a separation of compute from compute.
True.
Right? Each workload gets their own compute sized appropriately for them, and they do not compete with other workloads using other compute clusters. And this is the mind shift from most other data warehouses or data platforms, is this idea that each workload gets basically its own warehouse. It gets its own compute cluster. It's operating against the data. There's no contention at the data layer. So if marketing wants more power, they can get it instantly. The other thing that's inherent here that drives a lot of business value and a lot of conversation is because there is no contention when these workloads are running between them, you can throw the assumption out the window that you can only load your data at night.
Yeah.
And from an on-prem world, this blows people's minds. Generally speaking, any DBA on the planet in an on-prem world will say, we cannot run our ETL during the day because we will block our readers. We will cause all kinds of contention. We'll eat up all the resources on the box, and our reporting will suffer. What this architecture does is instantly remove that assumption. Now think about the business value that can be driven by removing that assumption and getting fresher data into Snowflake without impacting your reporting and operations.
Yeah.
That's the simplest use case in the world for how Snowflake fundamentally changes how data is leveraged within organizations. And it's just inherent to the platform. So, Tim's going to keep going through this and what we can do from a scale perspective, but it's extremely important to think of this as separation of workload, true separation on non-shared resources. So there is zero contention across all of these different user groups or workloads or whatever you want to call them.
Right. And one of the beauties of that is that I don't have to think about things like, well, I know that somewhere down the line data science needs more. So I have to build them oversized, and I've got to waste all of this money and resource because they're only doing it once a month, but I can't go and add to their environment, on a monthly basis and just take it away the next day. And by the same token, I don't have to worry about finance running out because I'm giving them too little, but they keep growing and they keep coming to me telling me that they're running out. So we take away all of that kind of problem.
Quick question. I understand what you're saying from a compute perspective. I'm curious, how does that have an impact from a data availability perspective, in the sense that I could be loading information into a table, but I might be reading information from that table from a BI perspective. Is it just more of a, as that query executes, it just takes that snapshot for what the data as is at that time, and then the next time a query executes, it's got new data? Is that kind of what happens?
Yeah, great question. So in the scenario where we're loading data while other workloads are happening, Snowflake is an ACID compliant, transactionally consistent database. So you will not get dirty reads. Any query executed against data while loading will only read committed data at the millisecond that the query began. And that is all driven by that cloud services layer that we showed earlier and kind of talked about as the secret sauce.
Sure.
That is the layer that controls transactional consistency. Now, you're probably right in taking the next step to say, well, that's also an issue. I now have really, really fresh data, but I may get a different answer than the person sitting next to me. There are ways to get around that as well, leveraging zero copy cloning, making sure that you do get consistent answers in your reporting environments. But it gives you options to either to expose the super fresh data or control that fresh data, but not have to do full batch loading all at once overnight. So in the scenario that I talked about earlier, where you can now load data throughout the day, the next question is going to be, oh my God, what kind of nightmare does that expose to our report writers? It's a different problem, right? But it's a solvable problem with cloning and using different environments to control the data that's being exposed to report writers and consumers. But yeah, ACID compliant, total transactional consistency at the moment of commit of data being written to storage.
So we're looking here at, we're going to go back and look at the data science piece here. And actually what we're looking at is we're going to look at the scaling up or scaling out of these clusters in the Snowflake environment. So when we looked this first step around the Snowflake, we looked at data science, and they're running with large, but they're in need of modifying models or creating new models, and they've got quite a workload that they need to get processed. So we can automate the ability for the cluster to upsize. We can go from large to extra large, and then right back down to large again. We can configure that to happen in an automated way, or we can go in and do this on the fly, take them from large to extra large without hurting anything, right, literally on the fly. In the marketing world, you see that they had the medium cluster size, but they've got a lot of people working, and so they have a little bit different problem where the data science people have more query running, right? They've got bigger, more complex queries. They just need more horsepower. The marketing people are adding people, and really they need more clusters. So they need to scale out, not necessarily scale up. So they're going to add more clusters to make it so that more people can work the load at a time without having a degradation in performance. And that too we can take care of very simply in the Snowflake UI. So,
Tim, can I'll
yeah,
add something here.
Go
So
ahead.
this is probably the biggest point of confusion for anyone new to Snowflake, is the difference between scaling up versus scaling out. Those are two very meaningful terms here. Scaling up is the data science workload, going up in t-shirt size, giving more computing power to individual queries. Scaling up or down will change individual query performance. So if you run a query on a large, you scale up to an extra large, you run that same query, chances are very, very good that query will run in half the amount of time as it did on a large, because you're using double the amount of computing power. That operation is a manual or human-driven change. The admins of Snowflake decide when queries are running fast enough and what amount of horsepower is correct for each workload. The system will not scale up automatically. It must be done by automation scheduled by a human, or a human changing the size.
I always screw that part up.
This is why it's confusing.
Yeah.
The scale out piece, which is the marketing example,
Oops.
will not make queries run any faster. Individual queries will continue to execute at the speed that a medium cluster provides. By scaling out, we allow more queries to be executed in parallel at the same performance profile. This happens automatically within the system. The Snowflake Query Optimizer sees that medium cluster 1 cannot handle another query. When another query comes in, there is no compute to be had. Most systems would queue that query until another one completes. What Snowflake does is it scales out to 2 mediums and load balances the queries across those 2 clusters. If 2 get maxed out, it will grow to 3 and so forth. As concurrency drains out, it will also scale back down in the same way. So scaling up, human-driven decision. Scaling out is a system-driven decision. Scaling up makes individual queries run faster. Scaling out makes more queries run at the same speed. It's confusing, it's weird, but this is the crux of administration within Snowflake, is making sure you have your clusters set appropriately to get the right performance profile to the right number of people. We'll definitely see this in the hands-on section, but this is the major point of confusion when thinking about how to properly size and scale your environment.
And I always get them backwards, so I have to pound that into my brain.
Yeah, once you see it in action, it becomes a lot easier to understand.
Yeah. So this piece right here is really different from what it was the last time I did a zero to Snowflake, and we're talking here again about that secure sharing and collaboration. So would you like to hit this piece as well, Jordan?
Yeah, I can. This is just another way to visualize what we talked about earlier of the secure data sharing, of different data sets being made available through different means and shared outside of your four walls. So everything we talked about with compute clusters and all that stuff is within your internal workloads. It's all your different users within your world. Whenever you get to sharing data with providers, vendors, government entities, what have you, that's where this diagram becomes relevant, right? That you can push data sets out in different ways and allow other entities to use their compute to leverage your data. So again, we're getting a little ahead of ourselves, but when you share data, you see the secure data sharing here on the right, or your private exchange, what have you. Those are simply listings and pointers back to your shared storage. When your vendors or partners decide to query that data that you're sharing with them, they use their own compute clusters in their Snowflake environment to query data sitting in your storage. So when, we'll go back to the IB Tech state of Indiana example. IB Tech shares enrollment data with the state. When the state runs a query on the IB Tech enrollment data, the state stands up a compute cluster and queries that data and pays for the compute. IB Tech pays for the storage of that data. So, it builds on itself. It becomes this kind of ecosystem with little bubbles of different sets of compute and different accounts, and it gets very complex very quickly. The thing to remember with all of this is when sharing data, the data provider pays for storage, the data consumer pays for the compute. And everybody, scales however they wish, within their own environment. This will be more real whenever we do the exercises in the hands-on lab.
For some of you that you work with FSSA or some of the MCEs, think how much better things would be as far as data exchange on Medicaid if everyone was using Snowflake. These data exchanges would make it so much better. So one of the other things that's really, I think, one of the most wonderful things about Snowflake that I've always liked is this zero copy cloning. So I can tell Snowflake that I want to clone my schema, my table database, and it happens in seconds, and people move on. So the real beauty here is that I can have people working in dev or test, and I've got this clone, but I haven't doubled the size of my storage. I mean, I cloned my database. I didn't increase the amount of storage space I'm using, because it's all done through metadata. So the database is still there, but the metadata has been cloned. So it's really a cool thing. It's the zero copy cloning is one of my favorite things, and we'll see that in the hands-on as well. So this is more in detail about that. So these common tasks of if we have a test or a QA environment, how do we make it so that we can test? In the case of most systems, well, all systems except for Snowflake, we are literally copying the data from one place to another. Our people work on it, do whatever their stuff is, but then tomorrow it's out of date. It's not the same as what's in production. So we have this issue of it always being old. And then there's always these chances that it's going to get screwed up in the creation of the new one stuff. So it's just this physical movement of data that we really don't need. It's costly and error prone. In the Snowflake zero copy data cloning method, this is just awesome. It gives us the ability to create clones of our tables. It's a metadata only operation. There's no data actually copying, no doubling of the environment, is what we're saying. So the modified data store has new blocks, but so what that means is that the unmodified data it's only stored once. It's new data blocks on my storage. It's not new storage.
And the other use case here for cloning that we see a lot, one is obviously dev test or other environments, right? Sandboxes, all that stuff. The other one is in regulated industries where for audit purposes, you must retain copies of your data for 7 years, right? Healthcare, financial services, all of these types of customers that you probably work with every day. To do that, our customers leverage clones that they snap a clone at the end of the quarter or at the end of the year, whichever, whatever your retention period is. They remove all read access to that clone and they set it aside until the auditors come along and say, let me see your data from 2018. They give read-only access to the 2018 clone, and the auditors have instant access to all of the data as it existed when the clone was taken on 2018, and the clones never go stale. You can sit them there forever because they are live storage. So anybody that's in insurance, healthcare providers, clearinghouses, revenue cycle management, clones are a way to get very simple, very cheap auditing compliance by simply scheduling regular clones and holding that data until it's needed.
Cool.
I'm looking for the like button. I can't like this enough.
No thumbs up. So this is another one that's wonderful, and every time you talk to Andrew about Snowflake, the first thing that he says to me is, and time travel, and time travel is you got to make sure you hit time travel. Well, Snowflake uses these what are called immutable blocks for data, right? They're unchanged, unchanged over time. They're always the same. So we can, using these immutable blocks, it gives us some incredible abilities. We can retain a period of data, time-stamped periods of data, anywhere from 24 hours, which is our default, to 90 days. And I believe you have to use the enterprise version or above in order to get the 90 days part. But you'll see in our hands-on piece, the data is stored by default 24 hours in this ability to use the time travel. So that gives us the ability to undrop a table, a schema, or a database. And have you ever thought, I mean, that is incredible. Normally, if somebody came in there and you hired an intern and they did an oops and they deleted your table, you'd have to go grab a backup and restore that. And then, of course, you'd have this empty hole from the time that it happened to the time of the last backup, and you'd have to recreate all that with Snowflake. It's undrop table, city bike trips. Wow, really? And it's right back there again. So that is just literally incredible. Or say somebody comes in and they accidentally change the value of a field across your entire data set that's gigabytes in size. Fear not, because using simple queries, Snowflake can go backwards and grab the timestamp, and restore back to that timestamp, or we can grab a query ID and go back before said query ID and restore that data too. This is one of those absolute game changers in the world because nobody does this. This is great. Andrew, did you want to add anything? Because I know this is your favorite part.
No, I think you covered it well. Thanks.
I will add one thing that's, I hope a lot of you have trial accounts for the hands-on piece that's coming up. I will challenge you to go play with the time travel features and use cloning at the same time. These two features can be used together. So imagine cloning a table. So create table, clone my sales table as it was 31 days and 12 hours ago. So you use the time travel feature to go look at the data as it was 30 days ago, and then create a clone table of that historical data. How you can flash backwards and forwards in time and create clones of objects as they existed at one point or another, anytime in that 90-day window. It just opens up a lot of really cool types of analytics that technically were very hard in the past, right? Think about dashboards that were, what are my sales versus 30 days ago? You used to have a table that existed 30 days ago as a snapshot. Now you simply query the sales table as it is today, join it to the sales table as it was 30 days ago, and you get your result sets. You can, outer join, inner join, however you want to do that. It gives you a lot of capabilities to create time-based data sets, use them in queries, and then potentially just scrap them after the analysis is done. So using cloning along with time travel, going backwards in time, coming forward in time, creating different objects. It takes a while to get the hang of, but it is a very powerful set of features that frankly is very hard to do in an on-prem world because of, spinning disk storage, where we have to delete records to create new ones. The immutability of storage in Snowflake gives us this capability by default. So yeah,
That's
play
great.
around with it. It will make your head hurt for sure, but eventually it'll click.
Yeah, we don't go that far in the hands-on, but since you have about $400 worth of credits to use, and we won't use nearly all of that in the hands-on, you can go and try these things. So Snowflake and business continuity. So this is really what we've been talking about here with the zero clone to some extent, but in other ways, so we have a customer error, we accidentally corrupt or delete our data, we use time travel to go back and take care of it. Fail-safe is not a word that I am familiar with in my Snowflake environment. So maybe you can help there.
I can hit on that. So we talked about the retention window for time travel being a max of 90 days. Snowflake built in failsafe, which is an additional 7 days on top of your retention window.
Oh.
But if you get to 91 days and decide you want that data back, you need to contact Snowflake support to have that data restored. It's not used very often, but it's an additional week to, make sure you don't miss by a minute, but use time travel, stay under your 90 days, totally fine.
Cool. So it's a customer service or technical support help.
Yeah, it's the whoops button. We waited 1 day too long. Yeah.
Love that. So say we have a single instance failure, the virtual machine fails due to a hardware system error, and I am reading that from here, but the Snowflake metadata manager, say you've got that sitting on one node and that node dies. Snowflake has this redundancy built into it, so you're not going to lose that so to speak. Your virtual warehouse node dies, you're okay there because Snowflake has the redundancy built into it. It's not going away. Say there's a zone failure though. We look at when we create our Snowflake environments, our databases and stuff. They are in availability zones. And there are times, due to things like power outages or natural disasters, different things where a zone may fail. Using it's always good to have things across multiple zones. In my work in Tableau, we set up servers for people, and we make sure that when they're multi-node environments, that we have a node that's set up in a different availability zone just in case. So we have the same thing in Snowflake with the built-in redundancy. The availability zones are, spread out across the United States, actually around the world, and we can restore or continue running literally from there. I wouldn't say restore. We just move our work is moved to that other availability zone.
So just real quick to provide a little bit more background here and how this would relate to your customers, right? Whenever they start to ask about business continuity and availability within Snowflake. To be very clear, for those of you that set up trial accounts for this session, everything we've talked about from zone failure up is inherently built into your account that you have today, regardless of cloud you set it up in, regardless of what region you chose. So if we're doing this lab and an entire availability set in Azure becomes unavailable, you will be able to continue doing your lab work without even noticing that there was an availability set failure in Azure. This is all part of the Snowflake service by default. If you have some VMs in your compute clusters that happen to die on the Azure side, don't worry about it. The Snowflake service automatically replaces those nodes for you without you ever even noticing. And by default, whenever you put data into Snowflake, your data is by default, without doing anything, stored in triplicate. So there are 3 copies of every bit of data you put into Snowflake. This is a happy accident by us using object storage behind the scenes to store the data in Snowflake. So from a data redundancy perspective, you're covered. From a data resiliency perspective, you get 11 nines of data resiliency by default.
Wow.
No backups. You do not have to run weekly backups of data in Snowflake because we handle the redundancy and the resiliency of your data in Snowflake. This is all within a single account that each one of you that set up the trial account now owns. So that's part of the power of as a service coming to life, is that this stuff you don't have to worry about anymore. Snowflake takes care of it for you.
So you want to hit the region failures for them?
Sure. So we'll look at another slide here in a second, but Snowflake has rolled out, and it's now GA. It has been since midsummer. Cross-cloud, cross-region replication. So everything we just talked about, where your compute is in 3 availability zones and your data is stored in triplicate, that's within a single region for one account. If you want to guard against an entire regional failure, which does happen in the cloud, you can replicate your data from Azure East to Azure West and have your data stored in triplicate in 2 separate regions, thousands of miles geographically split. So, Azure had an outage this week. Microsoft 365 was down because they had an AD issue. So, these things do happen, and you can have availability problems with Snowflake because of the underlying cloud infrastructure. So replication across regions will guard you against a regional outage within a single cloud. Some of our customers need 100% availability, so they want to guard against an entire cloud outage. So like I said, Azure was down this week because of Active Directory being down. You can replicate your data from a Snowflake account in Azure to a Snowflake account in AWS or a Snowflake account in Google. And in the event of a cloud outage, you can fail over to your secondary in Google and continue your business operations in a secondary account without missing a beat. We do now have transparent failover as well, which will repoint your client drivers to the secondary region on failover. So all of your BI tools, everything that's pointed at your Azure region, when you issue a failover and your primary becomes Google, all of your ETL tools, all of your BI tools will repoint as well. We're doing all the DNS magic behind the scenes to make that happen. So depending on your customers' appetite for disasters and outages, we have answers across the board to all of those RPO and RTO requirements. The thing to ask, especially from a consultative point of view, is to ask your customers what they're doing for business continuity today. Because I have a feeling that most of them feel very secure in what they're doing, and chances are really good that what they're doing is no more resilient than what they get with a single Snowflake instance. They may have 2 data centers. Those data centers may only be 30 miles apart. One major flood could potentially knock out both of those data centers. You get that by default with Snowflake in a region, because a region's actually made up of multiple buildings, multiple data centers, and multiple power grids. So understanding what their tolerance for an outage is and architecting the environment to meet that need is very simple, straightforward, and it's all built into the Snowflake platform. So just wanted to, walk through these, because this, anytime anybody's thinking about moving to the cloud, this is a big question mark, is how do I make sure that my systems are available in the event of a cloud outage? I'll hit this one too. So this is a simplified look at replication, how you can move data from region to region or cloud to cloud. Here's the really cool part of replication and DR and business continuity in Snowflake. Because all we're doing is replicating the data across clouds or across regions, you only pay for the storage, and storage in Snowflake is insanely cheap. I could do the calculations, but trust me, it's the cheapest storage you can find out there in the world today. So keeping a second copy of even hundreds of terabytes of data in another cloud, you may be able to have a full DR, replicated environment for a few $1,000s a year. You only pay for what you use. So if you're not using compute in your secondary, all you're paying for is storage. So, I have a FDIC regulated bank. Well, they're on the East Coast, but some of their headquarters are here in Indiana. They are replicating 250 terabytes of production data from AWS East to AWS West. West is their secondary. They replicate the data, I think, on a 20-minute schedule. So they have 20 minutes of lag between their primary and secondary. They could go lower if they wanted to. Their entire DR environment is running them about $61 a day. So they're paying $61 a day to guard against an AWS East regional outage, where they could flip their operations over to West and continue going just as if nothing had happened. That is almost impossible to do with any other tool out there. I mean, it's impossible to do on-prem. You have to buy double the hardware. Snowflake makes it very cost-effective to protect your data across clouds. And if you want to replicate to all 3 clouds, we can handle that too. If you want your data to sit in Australia, Europe, and the United States to be protected, we can do that as well. So it really is a kind of a game-changing type of technology on how to protect and move your data around the world.
So hopefully this slide now makes a lot more sense. This is what we started with, right? We can see, I'm not going to walk through these again, but as you look through this, I think we hit most of this, maybe not the semi-structured, but this fact you can store semi-structured data. But I think we've copied all these at this point.
These are some things that you'll need if you're doing the hands-on lab. And if you're not a technical person, or this doesn't spark interest in you, you do not have to stay for the hands-on piece. But you need to make sure that you have, to do the hands-on, you have to have gone out and registered for the free account. I sent the email with the reminder on that yesterday. So if you haven't done that yet, do it during the 15-minute time, and Jordan's here to try and help us push those through quickly. And then you'll need the scripts. The script file is located in Teams, and you really should have the hands-on lab, not required, but the guide is invaluable. So that's also sitting in Teams, and you'll want to grab that too. Well, I would sure like to thank all of you for sitting here and listening to this and watching. If there are questions and you just don't have the heart to speak up, you can always email me or send email to Andrew as well. We'll be happy to help you with those questions. Otherwise, thank you very much for attending this first part.